Welcome to Professor Russell Esposito's channel on information security. This video is just one of many video modules that are part of Professor Esposito's course on the subject. Video modules for his entire information security course are located on this channel. So remember to hit the like button as well as subscribe if you enjoy the video. Thank you for watching.
Access control. Sometimes I refer to, in a broader sense, identity management. But we're going to focus on access control, which is how you get your ID and password, how it's assigned to you, how this allows you to get access to a network and your applications, what's going on under the covers. So let's take a look at that now. Okay, let's take a look at logical security. We looked at physical security. One type of logical security is called access control. We looked at this a little bit in the very first module. We'll go into it in a little bit more detail here. But there are lots of other technologies and techniques that can be considered logical security. We're going to focus here on access control. As you can see from this slide, the processes and options for access control are many, and we'll cover these in detail in this module. If you recall, in the first module, we talked about some of these terms: authentication and authorization, and also identification, which is the first step for access control. Identify who you are, driver's license. You get an ID and a password. When you log on with an ID and a password, and maybe a multi-factor PIN number, if that's an option being used, you authenticate yourself. And then authorization is the middle of the screen here, the slide, which shows domain control, usually Microsoft Active Directory, and you get access to your systems and your services. So we'll add one more here called accounting. And accounting is really this AAA concept that is used in the security industry: authentication, authorization, and accounting. And accounting is a way to keep track of how resources are being used. So sometimes there's a charge back to a department, or a division within a corporation in terms of how resources are being used. So there's some record keeping of what's going on. And sometimes it could be used for if there's a problem, if there's some issue with IDs, passwords failing often. It may not be a user, it could be a hacker. So accounting could be used somewhat for auditing as well. Which brings us to the next slide. We're going to add a fourth A to this process called auditing. So we'll have authentication, authorization, accounting, and the next slide we're going to talk briefly about auditing. So this slide adds a fourth A to the AAA, and that's audit, because audits are really important in security, obviously, looking at logs from whether firewalls or routers, or machine logs or security logs in hosts. And we're going to learn more about intrusion detection and protection systems. There are logs there, obviously. So auditing going on and going back, and particularly auditing who has access to what. As employees change roles in companies, do their system assignments change appropriately? There's a concept of least privilege. You should have the least amount of access to the system to do your work and nothing else. You shouldn't retain access to systems you no longer need if your job changed. And also, maybe more importantly, when someone leaves a company, you need to audit to ensure that people who've left the company, that their privileges have been disabled, that they can no longer access the systems. So auditing, we'll talk about that later on in much more detail, but it's a key concept. This authentication, authorization, accounting, and auditing are key concepts in AAA in security, the AAA concept and the Quad A concept as well. And now what we'll do is let's go back to when you log on. We're going to have a few slides that really show you what happens under the covers when you log on, and what are the systems doing, and how does this happen? How do you get access to the network and to systems? And we'll go through that in the next few slides. In the previous slide, we looked at sort of a simplification of Active Directory managing access to the system. Microsoft Active Directory is a domain controller, just one type of many, but there's a couple more steps actually. So the first step, there's something called a radius server. That's the very first step, and the radius server gives you access to the network, and it checks against Active Directory AD or whatever the domain controller. In this picture, it's that gray box with the dots around it. I labeled it Microsoft AD Active Directory, and there's where it's looking up the ID and password to see if it's valid, to let you onto the network, and also The radius server gives you the ability to connect to a third-party, multi-factor, two-factor authentication. So that's over to the right where those three little drums are, additional third-party two-factor services. So the radius server has that ability to check AD, check a domain controller, make sure you're a valid user, and also manage and process any multi-factor authentication. And that gets you onto the network, and that's the very first step. I also put a note here that there's a lot of different protocols under the radius server. Radius is an open source. TACX is an obsolete CISCO protocol, but TACX Plus is a newer version, and it's superior to Radius. But you'll hear the term radius server as a generic term, but sometimes they're running TACX. Just a little detail for those who might be wondering what those terms are below the radius server. But the bottom line for you to understand is you log on to the radius server first. It checks Active Directory or the domain controller, ensures that you have the right privileges to access the network. It'll process multi-factor authentication if that's in the loop here in the picture, and then it lets you onto the network. That's the first step. So now you're on the network, but now your credentials shouldn't be used to get you on into other services, applications, or print servers, or whatever other services are available on your network. So there's this other product invented by MIT actually called Kerberos. Kerberos is named after the three-headed dog of Greek mythology. And what Kerberos does is it gets your authentication from Active Directory. By the way, that term LDAP on the bottom, that's just a protocol that is used to authenticate you. That's LDAP, the Lightweight Directory Access Protocol. It'll be discussed in another module later on. But just in case folks are curious about that LDAP term in the Active Directory box. But anyway, you authenticate with Active Directory. Radius server does that first initialization, gets you onto the network. Now Active Directory says, okay, I want to get you onto certain applications or print servers or whatever other services you're entitled to. But rather than use your password and ID to get you onto those servers directly, Kerberos gives you a ticket. So this way, tickets are used and not your ID or password. So your ID and password is no longer moving around the network. These tickets are. So that's the beauty of Kerberos. So Microsoft always uses Kerberos. Active Directory is always installed Kerberos. It's much safer than continuing with your ID or your password to get access to applications or print servers. So these tickets are assigned, and you don't need to know the details of the tickets. I have a slide to show you, but let's look at the next step after Kerberos lets you onto your applications. So you authenticated with radius server. That radius server checked using the LDAP protocol, checked Active Directory, AD, you're valid. You move on to Kerberos, you get your tickets, and now you have tickets to access applications, print servers, other services on the network. And now you're in. But see, it was a few steps, right? It's not just the Active Directory in that first picture, the slide several slides ago where we introduced you to the concept. So Kerberos, again, this is details that you don't need to know a lot of these details. Just understand what Kerberos does, that it provides tickets. But Kerberos has this key distribution center, KDC, and there's two parts to it. There's an authentication server, AS, in the first paragraph here, but that's really Active Directory, right? That's a generic term, authentication server, but Microsoft Active Directory is what's usually used. And then Kerberos has its own ticket granting service, TGS. And as I mentioned earlier, AS is just the term for a domain controller, an example, Active Directory. And the third paragraph here just reiterates what we said earlier. Tickets are used to access various applications and services because you don't want to continue. It wouldn't be safe to have your ID and password move around the network once you authenticate. So that's the concept of Kerberos. So here's a picture of how Kerberos works. And to the right, there's the KDC, the key distribution center, and that's comprised of two things. It equals AS, authentication server, usually Active Directory for Microsoft or some kind of domain controller, and then the TGS, the ticket granting service, the triangle. So the KDC is composed of those two different things. And then you can see the tickets go back and forth. I don't expect you to have the details in your head on this, but once you get your tickets, and then you can you access your resources on the bottom of the screen. So I just wanted to give you a picture for those who are more interested in the details. But again, just have an overall understanding of what Kerberos does from a high level. And now we're going to switch gears and look at access control models in the next slide. And this is how you assign users in Active Directory or a domain controller. There are different ways you could assign rights to individuals. And you can see there's, this usually what's used is role-based security, that you get a role that's already defined. So it just saves a lot of work rather than defining each person individually in terms of the applications and services they could use. So we'll switch gears now and look at access control models. So here, let's take a look at the access control models. Typically, there's a role-based security model, so that as you enter an organization, whatever your role is, whether it's a call center analyst or expert or claims processing analyst or forms analyst, somebody that processes a particular function, or they're a manager and executive, you'll be in a role, so that there isn't sort of individual access tied to each individual company. A large company, that would become very cumbersome. So this way you're associated with a role. The role, if there's changes to that role, affects everyone in that role. And it's much easier to manage. And then there's rule-based security, which complements that. And rule-based security is things like, the password strength, the complexity, the length of it, how many times you can improperly log on before you're locked out. And there are things that you don't maybe consider, but the length of time between those attempts, right? So if you attempt every 10 seconds, you might get locked out if you fail to properly log in 3 times. But if you wait 2 hours or 1 hour or a day, whatever that setting is. So these are rule-based things. Password history as well, as I'm sure you've experienced. You can't repeat a password. You can't repeat a certain sequence of numbers or characters in a password. It's got to be different enough to pass through. And passwords expire over time. So those are the rules-based. So roles-based is who you are in an organization, and you get associated with a role, and you get access that way. Then there's rule-based security, which is these other pieces we talked about. And then there's, obviously combinations of those. And there's some other things called mandatory access control. And these, again, will be used in tandem. They'll be used as a combination. Mandatory access control of things like the rule-based security. Things that IT controls, that somebody at a senior level in IT is controlling this. There's this, and maybe even assigning, like executives may have somewhat different roles. They may have individual security access. They may not be in a role because finance might be very different than IT versus the CEO. But then additionally, you'll have discretionary access control. So if you're the vice president or director of a very large organization, like a call center where you may have hundreds of people and a lot of turnover, IT is not generally going to manage that at the individual level. They'll help set up the group roles, but there'll be somebody in that line level organization, in that operational organization, that'll take care of new hires, transfers, people who have promotions, and manage the rights and the access for that 200, 300, 500 group department. So that's called discretionary access control. Now, we already talked about rule and role-based security. So those are the ways, the models that are used to really control access to a system. So the fundamentals of multi-factor authentication are these 3 particular areas. So it's something you know, password, something you have, smart card or token, or token could be a code you get to your phone that's in addition to your password that you need to identify who you are. And then something you are, fingerprint, a retinal scan, a facial recognition. So 2 of those things becomes a multi-factor authentication. Any 2 of those. And as far as the codes, there are 2 types of codes. When you get a token or a code sent to your email or sent to your phone, there's a one-time password that doesn't expire, and those are called HOTP. More commonly, you'll get something called TOTP, which is a one-time password that's timed, and it'll say something like, you need to use this code within the next 15 minutes, or the next hour or 2, and after that, the code is no good anymore. So there's some nuances in terms of how these are done. Okay, we talked about authentication, and then the next step is authorization. So authorization, let's get a little bit deeper into that. Authorization gives you access to certain objects, or files or folders, But then there's also actions. Can you read? Can you read and write? Can you delete? Updating. What are the actions that you have permissions for? So it gets a little bit deeper in terms of that. And also there's it's important and sort of very valuable to separate authentication from authorization, because there are different there's advantages to that, because there are various methods that can be used to perform each task. And separation allows for various combinations of each task. Any system or resource, whether it's hardware, router, workstation, or software component, or a database system that requires authorization, can use its own authorization method once authentication has already occurred separately. This makes for efficient and consistent application of these principles, and that separation allows for a lot of variability and flexibility in terms of how you implement these two functions, that is authentication and authorization. So users get, after they authenticate, they're authorized, they get authorization, gives them permissions to access a granted object, a file, a folder, a database. And then they'll have rights. What can they do with it? Can they read, write, delete, as we mentioned earlier? And that combination is generally called privileges. And there are some other I guess attributes or nuances in terms of how this is done. So that, for example, if I have permission to access a particular file, but I don't have the privilege to log on to this remotely, then I won't have access to it. And this is all controlled through something called, you may hear this in ACL, an access control list. An access control list really is a list that's associated with a file, so that file knows who the users are that can access that file and what can they do, what are their rights, and what are their privileges. So that's sort of getting into a little bit more granularity on the authorization concept.
So earlier we talked about role-based privileges, and these are great for large corporations where many individuals are employed. Rather than setting up privileges for individuals or rights for individuals, you assign them to a role that already has the pre-designated roles. But it's important to keep, to review these to make sure that people are in the right role. And that if the role is changed, you're affecting many, many people. So that maintenance has to be done very carefully. And you also need to look at the second large bullet here, user access reviews, to see that individuals in the company have the least privilege, that they don't have privileges that they shouldn't have. And that can happen when they change jobs, when they move from one department to another. The review needs to take place to ensure that these individuals have the right privilege and the least privilege, and that it changes appropriately, or that when employees leave the company, that they're taken out of the network, they're disabled, that you don't really delete access, but you want to disable the access, and you want to disable access to individual applications as well as access to the network. So, role-based privileges, great for assigning individuals to a role, much more efficient, but you have to do the maintenance to ensure that when the role is changed, it's changed carefully, because it can affect many people, and that individuals are moved from role to role appropriately. And then, of course, a final comment on generic shared accounts. We should never have an account that's, for example, ID employee and password welcome one. Those are the kinds of things that a hacker can discover through a rainbow table. It's a common sort of a combination for a password, and they should never be shared passwords.
Let's talk about different kinds of special or privileged accounts, and there are service accounts we'll talk about later, but these accounts are generally the administrator of a system. So the administrator of a Windows system or the root account of a Unix system, these are called super users, and they can do anything to the system, right? They're the administrators. They have full access to all the volumes, all the files and folders, and they require monitoring, and usually real-time monitoring. You really want to know what your administrators and your root accounts are doing during the day and getting an understanding, because if a hacker has gotten control of an administrative account or a root account, they can create some serious damage to your system. So you want to make sure that, like for example, if somebody's accessing a system through administrator or root 2 o'clock in the morning, or from a very odd IP address, remote address that's typically not part of your network, that for some reason wasn't blocked through your firewall, or something was spoofed, you really want to know that pretty quickly. And the other thing is, these accounts should only be used when it's necessary to use those higher privileges. So if I'm an administrator, I shouldn't log on just to do email with my administrative account. I should log on with I should have another account for a typical role that I'm in, and not use my administrator account and password, and only use those for when I need to use them to load software, change a system, do some higher privileged work. And the reason for that is you don't want these passwords, transacting or transmitting through a system, all day or on and off during the day or frequently, because it makes it just easier. The risk of somebody picking that up, a hacker, is greater than if you use it very judiciously and only when you really need to use those quote unquote superpowers. You should also be aware that there are things called service accounts, and these are internal accounts that allow systems to talk to each other. And generally, these logons or these identities and passwords cannot be used to log on to a system as a user. They're specifically defined for particular systems to talk to each other, and they may have time restrictions on them. So when certain, let's say, batch work happens in the evening or after midnight or something, it may be limited that these service accounts can only work during those hours. And of course, you need strong passwords for these to make sure that they aren't hacked, and take care when changing these to prevent unplanned outages as well. If you're changing something changing a password that runs a couple of processes, be cognizant it may run a couple other processes that you didn't document, and something could stop running because you changed a service account and you thought it only affected 2 interfaces when it affected 4 interfaces, for example. So these service accounts are important. You just need to be aware that they exist. And I'm sure you've all had access to guest accounts at some point, where a company has an account if you're a visitor or a guest, and you just have access to the internet and very limited access to whatever you really need to do the function if you're a consultant. So they're important to have. There's nothing wrong with using them, or they're sometimes used for running a kiosk, where you sometimes you go to a kiosk. It's very typical in today's time for one of these urgent care centers to have kiosks, and the machines are logged on and they have these guest accounts, and there's really no need to log or track the activity, because you don't know who's doing it, right? I mean, if something happens with one of these guest accounts, you have to figure out what went wrong and how to ameliorate it and how to respond. But logging it and tracking it is kind of useless because you really have no idea who the user is.
Audits and monitoring, very important in information security. So audits, for example, we have certain individuals in the company with elevated privileges, elevated rights, administrators in IT that can create systems, create databases, to delete databases, change the way they're configured, change systems, change the operating system. So these individuals have what's called elevated administrative rights. But they should not be using that ID and password for their routine tasks. Those individuals get 2 IDs and 2 passwords, one for elevated administrative rights, and that logon should be used judiciously, not all day long, for their routine tasks, simpler tasks, or doing email or doing spreadsheet work or Word documents. They'll have a second ID and password that does not have elevated rights, and that should be used during the day most of the time. So these audits should look for abuse of that. Someone may log on with elevated rights and use that ID and password all day long for many different tasks. So you won't know that unless you're doing an audit. And then you have to counsel that person to say they have to log off and use their typical, the lower status rights for routine work. And the main reason for that is you don't want these very powerful IDs and passwords floating around the network all day long. That just increases the opportunity and the risk that a bad actor, could pick up that identity and that password. So continuous monitoring, example in the second large bullet here, failed logins, monitoring if there is some attempt for someone either locally or remotely trying to access systems they're not really supposed to be accessing, or they may be hackers. Look at the time of day, the length of the connection, what's been accessed. Is it unusual to have a connection for a file transfer that's longer than typical? Maybe this particular logon is for half an hour a day or for 2 or 3 hours, but then an audit shows it's online for 10 hours. So there are different things you can look at, and there are alerts that can be, retroactive in terms of retrospective, I should say, in terms of looking at, let's say, how well we maintain our changes of roles when individuals move around the company in terms of their position or change jobs within the company to different departments. You can look back and see if that's happening. You can look back retrospectively to see if people who resigned no longer have access to the network and other applications. Or you can monitor things real time. You can monitor elevated rights to see if they're in use during the day, how often they're in use, is it out of scope in terms of what you typically see. Is it something that's an aberration, something that looks unusual? So audits and monitoring, you can have text messages sent to you, emails. Obviously, there are dashboards for certain kinds of reports, reporting systems we'll talk about later on in the course. But this whole concept of monitoring and auditing what's happening is obviously very key for information security.
There's another type of authentication beyond the authentication that we talked about, whether it's single factor or multi-factor, and that's this protocol called 802.1x. And what this protocol does is it requires you also to have access to a physical port, on a server or on a switch or a router. There are also logical ports, which you may be aware of, typically like port 80 for internet traffic or 443 for secured internet traffic. Those are software ports. Those are not physical ports. 802.1x relates to a physical port on a machine. And when you have this in place, it makes it impossible for someone to go into a closet and take a laptop with hacking software on it and plug their laptop into the back of a switch or a router and get access to your network. So it's a good protocol to embrace. It's becoming more common, and it's very commonly used with wireless access points as well. So that when you log on wirelessly, you also have to have access to the proper port to access the network via your Wi-Fi device. And there are some other pieces to it in terms of, if those who are interested, it's called EAP TLS and PEEP TLS, the more secured kinds of encryption that's part of the 802.1x protocol. So this is just another level of authentication that you find common in companies and organizations that have this physical port-based authentication requirement. A very popular function is SSO, or single sign-on, where you sign on to one authentication server, and that gives you permissions to multiple devices. The user of multiple functions or services, platforms even. So the user signs in once, providing a username and password to an SSO server. You've all done this when you're using Google or Facebook to access other services, where they say create a password and an ID and a password, or log on with Google or Facebook or something like that. So the single sign-on server provides authentication information to any resource the user accesses during that session. The server interfaces with other applications and systems, and you don't need to log on a second time, obviously. So in reality, sometimes this is complicated to do. It may not be as simple to do as it may sound. And sometimes vendors, when they bring another foreign system in, talk about single sign-on and how it'll be easy for your organization to implement single sign-on and not have a separate sign-on for that new application or server. But it can be complicated. There needs to be some similar sort of architecture between the systems. And what some companies do is use it's a good product. I'm not necessarily recommending it, but Okta, OKTA, is a very popular company that's used to manage single sign-on and to provide single sign-on. And it's very much, it's a nice product. It's been a very popular stock, I should say, over the years, several years. And it's grown a lot, the company. It gives you basically your company a sort of a dashboard, I should say, of tiles, where you could manage each tile as another application. You could simply manage your single sign-on through this Okta platform. Not an inexpensive platform, but it is an option I think you should know about. Without getting into too much detail, but I just want you to be aware of the two most common protocols that are used for single sign-on. One's called SAML, security assertion markup language, and the other is called OAuth, Open Authentication. And these are actual protocols that are under the covers that provide for single sign-on. So I'm sure Okta, unless they've coded their own proprietary protocol, which I doubt, I would think they're probably using one of these protocols that your IT department would use should they take on the task of interfacing multiple systems, under a single sign-on server. These would be the protocols they might use, and OAuth is probably a little bit more popular today than SAML, but they both work and they're both common in the industry. So the National Institute of Standards and Technologies, NIST, it's a federal agency, not regulatory, but advisory in nature only. In 2017, they updated password management concepts. So in this slide here, you have 1, 2, 3. Number 1, they recommend multi-factor authentication, which we talked about earlier. Number 2, here in the slide, they talk about using a unique phrase rather than using a very difficult password that has a lot of special symbols, and sometimes an S is replaced with a $sign, a 3 is replaced, or an E is replaced with a 3, and it gets hard to remember. They're saying keep it simple, use a phrase, but don't use a hackneyed phrase like let the force be with you. That could be in some sort of hacker's dictionary. But you use a phrase, make something up. In this example, it's Sunwalk Rain Drive. Make it simple. You could add an exclamation point or an asterisk at the end of it if you like. But the key is it's got to be more than 12 characters. That makes this password inordinately difficult to crack. So an 8-digit password, even with all the special characters, is a lot easier to crack mathematically than something that's 12 or more positions. When I first heard of this new NIST requirement, I thought I'm never going to use 12-character passwords, too long. But if it's a phrase, it's kind of simple to remember. So it's easy to remember, hard to crack. That's the new standard. And number 3 here on the slide, it speaks to a unique phrase. Don't use the same unique phrase. Don't use the same phrase for your bank, for your email, for your insurance company. Use different phrases. Make them, if you want to make them sort of similar, maybe that's okay, but don't use the same password, because if you're identified, if someone gets into your bank, they may find your email and get into your email, or vice versa, which would even be worse. So this is the newest recommendations, or an updated, I should say, recommendations from 2017 from NIST regarding passwords. The National Institute of Standards and Technology, a nonprofit, non-regulatory organization that sets lots of different standards for many industries, that they provided, 20 years ago, some recommendations on password security and the complexity of how passwords should be created. So if you look here, they've changed the guidelines in 2017 rather radically. So if you look at the arrow here that says old guideline, here's the word troubadour, and you can see this is sort of the standard, fairly standard historical way of spelling it in a weird way. So the O is really a 0, and the A is the number 4, and you sometimes you might have like an L to represent, a 1 to represent an I, or an L might represent a 1, but it gets kind of complicated. But this was their recommendation. And if you look at the sort of the center slide, the center box in the top, it talks about the number of bits of entropy and how complex it is. It's relatively easy for certain calculation algorithms to figure out what the password is. Not easy, but in today's world of the sophisticated chips and things that people use for these rainbow tables and stuff, they kind of figure it out. But it's hard to remember, so it's easy to hack, relatively easy to hack. But as time went on, it became easier, I should say. And it's hard to remember where you use the 0 or a letter, or how you sort of rearrange the alphabet with numbers in a complex way. That was the old standard. 2017, the same author who created the old guideline admitted that things have changed, and he recommends now the new guideline, which is 12 characters or more. Now, at first, don't bristle at 12 characters, which I did originally too when I first heard it. But you could do a phrase like this phrase here: correct horse battery staple. It makes no sense. It's not something somebody's going to guess. But if you can remember that in your brain, Those 12 characters are much harder, as the center box shows, to guess, and 44 bits of entropy, and it would take something like 5 or 50 years to guess at 1,000 guesses a second. And in the right-hand box, you could have a little picture in your mind of this correct horse, battery, staple, or it could be, umbrella, rain, walk, run, umbrella, rain, sun, walk, or something. I mean, things that nobody's going to guess. You're not going to use something that's sort of a hackneyed expression that someone will guess, but something that's odd, but something that you can remember pretty easily. But it's got to be 12 characters or more. But if it's 12 characters and it's easy to remember, most people will not bristle at that and will adapt it. And that is the new recommendation. And I certainly I've embraced it, and I've been using it for a couple of years now. And the bottom note is just kind of a funny comment. Through 20 years of effort, we've successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess. So, and that's kind of true. Now, again, over time, it's become easier for computers to guess with different techniques. But so I just wanted to make sure you were aware of this new password complexity recommendation from the National Institute of Standards and Technology, aka NIST. Thank you for watching, and stay tuned for Module 5. And in Module 5, we'll begin to look at the fundamentals of a network.